Good morning, sir.
Good morning. How are you?
Good, how are you?
I'm good. Thank you. Right. How are you? Ilyas.
Good morning, sir.
Good morning.
Maybe we'll get hamburgers for lunch.
Okay, guys, will you please say your name one by one? Okay, let me speak for you. Solomon Harris, Gage Levine, Stein,
Yes, sir.
Alex,
Yes, sir.
Rodriguez, Nathan Light,
Here.
Ilyas Tyson,
Here.
then who is next?
Will Hosteller. I'm here, sir.
Oh, that's good. Finally.
Yeah, I figured it out.
Good.
I'm still on my phone, but I figured out a way to have it
That's good.
with
Thank you.
with me not
I
having to hold
appreciate
it.
it. Thank you. Queen Heart, I can't see you. So 7, then 8, 9. And who is left out? Yeah, Queen Heart is here. Okay. Can you hear me, Queen Heart? Yes or no? Just say something, please.
Yes, sir.
It's
Can you hear
hard
me?
for me. Got it.
I'm at Panera right now, so it's a little noisy over here.
Okay. And who is left out? Margie? Margie Vyas? Okay. So all are here, right? Except one. Okay, guys. So did you submit your homework?
Yes, sir. Submitted at the same place I submitted the test.
That sounds good.
Yeah.
That's what I want. Really nice.
All right.
So all of you, please make sure that you have submitted your homework and the exam. And I graded your exam on the same day in few hours. Am I right? And you got that message.
Yes, sir.
Okay, good. And Ilyas is not there. Ilyas?
Sir. Yes, sir.
No, not Ilyas. I'm sorry. Ismail.
This is here.
Ismail is here?
Yeah, I just joined.
Oh, you just joined. Okay. Tired? Tired?
Yeah, kind of.
Okay. I can understand. And Margie Vyas is still not here, right? Okay. Guys, have you checked your Canvas file section? I submitted your 4th test, practice test assignment. For 3rd practice test assignment for chapter 4. And that is something like this. Look at over here. Let me share the screen with you. Where is it? Oops. No, why it's not here? Last notes, no, it's not here. Oh, see is here now. Try to comment.
Sorry, it's making me update Zoom for some reason, so it took me 5 more minutes to get on.
Yeah, I do the same thing.
Yeah.
Okay. Yeah, so let me just double check. My chapter 4. Okay. Ridiculous. Why I can't see that page which I just opened for you guys? Is it here? No, it's not here. Excuse me. Margis, try to set up your video. It's in the reverse way, like this.
Like this?
Yeah. Oh, no.
Like this?
Yes, like this.
Okay. Sorry, I'm on my phone because my laptop was updating.
Okay.
All right, how's it going?
Who is there? Let me open my file again. What's going on? I open the file, then I'm just sharing that one with you guys. Yeah, and it's here. Okay, so couple guys requested me at the end of the first test to provide the answer keys, and I did this thing. I worked really hard for you guys and try to give you the answer keys for this one. Red color lines, red colors, that's the answer keys for each and every question. Look at over here, question number 4F. You can see y double dash minus 8y dash minus 20y equal to 100x square minus 26x e to the power x. Right? And answer is this one. But if you change slightly, instead of this minus, if you take plus, then the answer is this one. It's a big change in the answer. So all these things we are going to see. First phase of your syllabus is over. Second phase is started now. We are going to start the second phase. That is the higher order differential equation. So far, we just dealt with the first order, first degree differential equation. Now it's a higher order differential equation. Again, the theme is same. I told you I like this book because he maintained the continuity. First of all, in Article 4.1, I would just like to provide you the introduction of higher order differential equation, solution of the differential equation, then superposition means linear combination of the solution of the differential equation for higher order, of course, now onwards. And then after, in Article 4.2, suppose you have second order differential equation, that means you have to have two solutions. Out of these two solutions, one solution will be provided to you, and we will be looking for the second solution. That is what Article 4.2. Article 4.3, this is Article 4.1 is over here, is linearly dependent and independent of the solutions also. Suppose you have cubic equation, you have three solutions. Out of these three solutions, how many solutions are linearly dependent or linearly independent? That's what we are going to figure it out. That is your question one. Question two, that is based on Article 4.2. As I told you, one of the solutions is provided to you. Look at over here, second order differential equation. y1 equal to x to the power 4 is one of the solutions. Second solution, we can figure it out using the formula and based on the first solution. Then after third part, that is Article 4.3. Article 4.3, please try to pay full attention. Whatever I'm telling you right now, that is the whole theme of the chapter or overlook of the chapter. Article 4.3, question number 3, that is based on Article 4.3. Article 4.3, that is the homogeneous linear differential equation. Now onwards, whenever I say differential equation, it is to be understood that we are talking about higher order differential equation. Means order is 2 or higher. Here you can see homogeneous, I use the word. Homogeneous means right hand side equal to 0. You can see over here in all these equations, all these examples, right hand side equal to 0. In example C, that is the initial condition. That's fine with the right hand side equal to 0. Whenever right hand side equal to 0, that is called the homogeneous linear differential equation. All are linear differential equations because the theme is same, dependent variable and all its derivative appears in the first degree. First degree. See, degree means power of the derivative. So here first degree, and they are not multiplied together. So they are linear. Right hand side equal to 0 means homogeneous. So homogeneous linear higher order differential equation, right? Then after, theme is completely different. Whatever we are going to do now, it has no relation with your first phase, means our chapter 1, 2, and 3. This is completely different thing. Please keep in mind this thing. Suppose somebody says that he or she has not performed well in the first 2 exams, that's fine. Still you have a chance because this one is completely different. Question number 4. That is the solution of the differential equation, undetermined coefficient. Undetermined coefficient, that means this is a non-homogeneous linear differential equation. Non-homogeneous, that means you can see my right hand side is not 0 now. It's not 0. Everywhere right hand side is non-zero. Now this right hand side could be anything. It could be just simply, just don't count e to the power negative 2x, just simply polynomial 2x plus 5. Just e to the power 2x, or the combination, or the same here, combination over here, or combination of exponential function with the trig function, or simply exponential function, or algebraic polynomial with the exponential function. See here, second order polynomial with the exponential function, or some algebraic function and exponential function. So it could be anything, any separate function, either exponential function, logarithmic function, tangent function, say trig function, or algebraic function, or their combinations. Any kind of combinations would be there, right? So whenever you are working with example 4, that is the heart of this chapter. Example 4, that is the main part of this non-homogeneous, or I would say higher order differential equation. Chapter 5, I'm going to provide you one formula. That formula probably you will not find in the book, but if you follow that formula, you will get the answer just in 3 to 4 steps. If you are going to follow the method given in the book, it will take 1 page, or I would say 1.5 pages. So I would appreciate if you can go for this formula, and that formula is really very easy. And that formula is included in the formula sheet. It's included in the formula sheet. Yes, I'm going to provide you one formula sheet too. Not one, probably 2, 3 formula sheets for this chapter. So count all these formula sheets, try to take the printouts time to time, because in the final, I will not allow you to open any of your windows, any of your technology, any of your computers or like this. You have to have everything on your hand when you take your final. I'm informing you well in advance so that at the last time you can't blame me, and you have enough time to take your printouts or manage your time, manage your materials. Good. So the question number 5, there is the method of variation of parameter. Whenever your right hand side function is something like some cosecant function, see, you cannot find cosecant over here or tangent over here, tangent inverse over here. Whenever your right hand side is that type of function, and second order higher order differential equation is there, it's preferable to go for, it's preferable to go for the method of variation of parameter. Unless you are asked to use this method, don't use this method. Always go with the method given. I'm going to give you in article 4.4 or question number 4. Next part is the system of linear equations. Now you are not going to solve just one differential equation. You are solving 2 equations simultaneously. Look over here. 2, 3, 4 equations simultaneously. And I provided you the answer keys also. A is here, B is here, C is here, like this. So that's what we are going to see in next 4 or 5 days. Today is Monday. So next 4 days, I would say, and Friday exam, your third test, right? So be ready, guys. 6 articles, 4 days. That means 1.5 articles a day. Sounds good? Yes. This is a summer course you have chosen, guys, and that's why everything will go really very fast. So I'm sorry about this, but we don't have any other option, right, guys? Because we are finishing just our syllabus in 5 weeks, which is usually, I would say, 14-week syllabus in a regular semester. So that's why all my videos, just try to look at the videos and everything. Yeah, guys, please try to look at the videos, try to watch the videos number of times, 2, 3, 4 times, because that will provide you more ideas. I gave you one advice last week. Again, let me remind you, and this is the last time. Then after, I'm not going to tell you this thing. I don't know how you prepare yourself for the exam, but the best way to prepare yourself is to go through the class notes at least 2 times. Here I'm explaining you each and every word, everything over here. And then after, if you find some time on the same day and try to go through the same lecture at least once, you will have a lot more ideas. And then after, you can start solving examples by your own. Keep your notes open on your window, on your computer, and then start writing on separate piece of paper, start solving the examples. You will find some problems at some points. Okay, fine, that's not a big deal. That's fine. Just try to look at the computer, try to look at the solution, and try to mark that point. Oh, this point is was bothering me. I got stuck at this point. Try to put a circle or some mark down that thing. Proceed further. Second example, third example. Again, start solving the same examples without looking any of the materials now. This will give you confidence. You will be getting more and more confidence. And then after, once you are confident, then try to solve the unsolved examples. That is the best way to take the good command of over any of the subjects. Any of the subjects. It's not just math, any of your other major subjects. If you prepare yourself like this, you will never forget the things, and maximum chances are there to secure good grades like A. Yeah, I'm not talking about your B. Trust me. And that's what I did throughout my life. Yep. So there is no option for the hard work. Good, guys. So advice is over. Let me start with the formula set. This is one of the formula set. Actually, I wanted to give you another formula set, but that's fine. Look at over here. You need to take the printout of this formula set. This is the formula set. This is for article 4.4. Non-homogeneous, method of undeterminate parameter. Or you can say practice test number 4. Example number 4. Article 4.6, practice test example number 5. This is the formula I told you. So you can take the printout of this page, and I will allow you to use this page in your exam. So one more formula set, right? I am not counting, but you need to count all these formula sets. At the time of the exam, if you ask me that you forgot something, so that is your fault. Please, guys, please cooperate me. So whenever I say this is the formula, I will allow you to use that one in the exam. That means it is in both the exams, internal and the final, and that is your job to arrange the hard copy of that formula set. Okay, guys, I will let you know how to use this formula when time will come. Right now, I would like to start with the introduction of higher order differential equation. Higher order differential equation. Okay, general form. In general, I would like to give you the nth order differential equation. Nth order differential equation. An(x) d to the power n y over dx to the power n. Look at over here. This is a1, n minus 1, an minus 2, a1 and a0. Right? a0. All are constants, a1 to an and a0, n plus 1 constants. Either they are constants or they are a function of x, independent variable, but there should not be function of y. Otherwise, it will create a non-linearity. And we say that it is higher order linear differential equations. Nth order linear differential equation, but non-homogeneous. Non-homogeneous means the right hand side is not zero. Not zero. One more thing. This is the nth order differential equation. That means you have to have n initial conditions if you want to convert this differential equation in terms of the initial value problem. Again, in first chapter, we just went through first, second, and third chapter. We just went through the first order differential equation because order was 1, and that's why we had just one initial condition. Now, order is n for this particular equation, and that's why we have n differential equations. N initial conditions. So one initial condition for each order, you can say like that. One initial condition for each order. So n order differential equation, and that's why we are having n initial conditions. Why I say n initial condition? Because every time you can see over here, x0, 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 x0. Everywhere my x0 is fixed. And that's why this is called the initial value problem. If this one is x0, suppose 1, and this one is not 1, this is 2, 3, 4, something else than 1. In that case, it will be considered as the boundary value problems. Most likely, we will not be doing in the depth of the boundary value problems for this course because of some time restriction. But right now, just try to understand the difference between the initial value problem and the boundary value problem. One more thing. Y at x0 equal to y0. My second condition that is related to my first derivative, second derivative, third derivative, finally n minus 1th derivative. Because n minus c is starting with 1, 2, 3, n minus 1th derivative, and first one. So including all these, we have total n initial conditions. N is initial condition. So nth order differential equation with n initial condition, that is called the initial value problem of nth order. Again, order of the differential equation. Here it is n, number of initial conditions. Here they are n. Third order differential equation, you have to have 3 initial conditions, 1, 2, and 3. So always it is in the increasing order in terms of derivative. Y to the power 0, y to the power 1, y double dash, like this. And you can see here my 1, my 1, my 1, they are fixed. That's why it is called the initial value problem. That's why it is called the initial value problem. So this is a non-homogeneous differential equation. Now the homogeneous portion is different. Homogeneous means your right hand side is not equal to 0, that is equal to 0. Non-homogeneous means right hand side is just function of x. Make sure guys, it has to be a function of x like this or some constant, that's fine. Because x is your independent variable. It should not be a function of y. Please keep in mind this thing. Or if it is 0, you don't have to do anything. So now, just to maintain the continuity, I would like to consider this equation. Equation number right hand side equal to 0. My nth order homogeneous linear differential equation right hand side equal to 0. I would like to consider as equation 6. Now onwards, throughout the chapter, whenever I say homogeneous or equation 6, that means I'm talking about right hand side equal to 0. And whenever I say right hand side is non-zero, that means I'm talking about some function gx, means I'm talking about equation number 7. So the other way around, if I say that equation 7 means it is to be understood that we are talking about non-homogeneous linear differential equation. Does it make sense? If you have any doubt, guys, you can stop me at the same time. You can stop me at the same time because this is really very important. It's the introduction portion. Just give me a minute. Okay, good. Now, the question is, if you want to solve this type of differential equation of higher order at that time, you cannot use just your previous or usual method of solving. It's completely different. You have to take the help of an operator. You know that derivative, integration, all are the operators. Derivative operates, suppose one function x square, derivative x square, derivative is an operator, operates on this quadratic function x square and convert that function in a linear function 2x. Right? X square derivative is 2x. So derivative is an operator. That is called a differential operator. Integration also is an operator. That is called the integral operator. Integration of x square. Integral operator operates x square to x cubed by 3. Right? So quadratic equation is to be converted to biquadratic equation. Biquadratic equation. Like this. So these are the operators. Hello? These are the.
Hi, this is Frank with Home Automation Pros. How are you?
These are the operators. I'm sorry, guys. Now look at over here. D by dx of y. Derivative d by dx, I would like to write it down by d. D as an operator. So actually it is d of y. So whenever now onwards, if you see d, means we are talking about derivative of that function, differential operator. That is d of y. Suppose I have, oh, my bad. Suppose I have y equal to cosine x. Y equal to cosine x. Let me, what's going on? Oops. Little bigger, makes sense. Okay, right? Bigger screen, that makes more sense. So y equal to cosine x. So y equal to cosine x means this function, yes, this function cosine of 4x, derivative is negative 4 sine 4x. So that this derivative differential operator operates on this function with the angle 4x and converts to sine function like this. Second, d square x y by dx square. That means it can be written as d by dx of dy dx. Dy dx, already you figured it out. Dy dx was nothing but your d of y. Look at here, dy dx is d of y. So let me plug this d of y. This is nothing but my capital D. Capital D and d of y. So d and d, you can open the bracket because operator is linear. So you can write d square y. D cube y over dx cube, dy dx of d square y over dx square, d square y over dx square, that is d square y. Plug it over here. D by dx stands for capital D. That means it is d of d square y. That means it is d cube y. Same way, if you extend this nth derivative, that means you can write in terms of d to the power ny. That means whatever I'm getting over here, see here, my first one and all this. I would like to write this, my derivative here, nth order, n minus 1th order. So nth order, look at the bottom, nth order, previous one is n minus 1, previous one is n minus 2, then 3, 2, 1, like this, 3, 2, 1, and finally 0. If you plug these values in terms of the operator, if you convert this equation 6 in the form of an operator, so I'm going to get anx d to the power n, d to the power ny. Look at here my cursor, please. D to the power ny. N minus 1x, an minus 1x, d to the power n minus 1y. D of y. And finally, simply y. I can take my y outside because every term includes y. Let me take my y outside. If I take my y outside, look at over here. I'm going to get an x d to the power n, an minus 1x to the power n minus 1, and y equal to 0. Right? This is nothing but I would like to consider another operator, Ly equal to 0. So whenever I say Ly equal to 0, that means I'm not going to speak that nth order homogeneous linear differential equation. It is to be understood that Ly equal to 0 means this one, equation 6 in the operator form, and Ly equal to gx means equation 7 in the operator form. Examples are like this. Suppose I have y double dash plus 5y dash plus 6y equal to 5x minus 3. Just one example, random example. So y double dash means my n equal to 2, an x is constant, is 1 here. Whenever you are looking for, suppose, second order differential equation, make sure your coefficient must be non-zero. Because if this one is 0, this part will be 0, and you are no longer working with the second order, you are falling down to the first order. And that's what we don't want. We are talking about right now the higher order differential equation. So please keep in mind this thing. Okay. So I would like to convert this one. This is a differential equation. I would like to convert this one first in terms of my operator form. You have to. So second order means I can write, see, d square y over dx square. D square y over dx square means it is this form. D square y over dx square, that is this one. Oops. D square y over dx square. Look at here, my cursor. That is capital D square y, like this. So let me write capital D square y. 5 constant, y dash is dy. 6 y. Let me pull my y out. If you take y out, d square plus 5d plus 6. This is my LD. Whatever LD I wrote it down over here, or Ly. This is my L of y. Polynomial in terms of y. This is my Ly. Now, please pay attention. Please pay attention, all of you. Whenever you are going to solve the higher order differential equation like this, my right hand side is 0, please, just for the sake of convenience, please. Right hand side equal to 0. So convert your differential operator in terms of an algebraic number m, some algebraic number m. So d is a differential operator, but just I would like to convert this one in terms of m. How? Because every higher order differential equation solution is obtained in terms of the exponential function, and there is a theory behind it. I don't want to include the theory, but right now, by replacing d by m, we are converting differential operator in the form of the algebraic equation. So differential equation, by replacing d by some constant m, is to be converted in terms of the algebraic equation like this: m square plus 5m plus 6 equal to 0. That is without y always. If you write the equation without y, d square plus 5d plus 6 equal to 0, without y, that equation is known as an auxiliary equation. So you have to mention like this: auxiliary equation, that is, differential operator is converted in terms of the algebraic number m without y. That is the auxiliary equation. Once you have the auxiliary equation, it's just like your 8th grade. It's now a quadratic equation because m is a real number. So it is just m square plus 5 or x square plus 5x plus 6 equal to 0 form. So use your FOIL method. M plus 3, m plus 2 equal to 0, m equal to -2 and 3. These are the roots. Now, guys, please be careful. I am going to bifurcate. I'm going to give you the bifurcation of my roots in 4 different parts. 1, 2, 3, 4. 4 different parts in your article 4.3, when actually we are going to solve higher order differential equation. But right now, you can say 2 roots are there. order is 2. So one more proposition I would say, that is order of the differential equation must be equal to number of roots. If order is 2 and root is 1, that is not going to happen. That's not possible. Order is 2, you have to have 2 roots. Order is 3, you have to have 3 roots. Order of 4, you have to have 4 roots like this, right? So order of the differential equation must be equal to number of solutions, or you can say number of roots. Depending on the nature of the root, you will be able to write the general solution in article 4.3, not right now. Right now it is article 4.1. We will take care of this thing probably tomorrow. I don't know, we'll see. Maybe later today. So I just wrote it down for your convenience. This will be taken care of. What is this? Yeah, this is, then we will take care of our right hand side. So right now I just worked with the left hand side. If your right hand side is 5x plus 3, here it is 5x plus 3, but intentionally I assumed my right hand side equal to 0, because first of all I just would like to take care of my left hand side, assuming my right hand side is 0. I don't want to touch that part. I don't want to touch that portion at this moment. So please solve this one. Once you are done with your left hand side, now go for your right hand side. How to go for your right hand side? That is article 4.4, undetermined coefficient, non-homogeneous portion. We will discuss this thing tomorrow. Makes sense. Makes sense. You need some more attention over here for this chapter, please guys. Once, whatever the solution you're going to get from this left hand side, auxiliary equation, that is called your complementary function ycx, y suffix c and x. That is called complementary function. Whatever the solutions you are going to get using your right hand side, here is 5x plus 3. How to use this one? Chapter article 4.4 later on. But right now, whatever the solution we'll be getting using that technique, that is called yp of x, y suffix p of x. That is called particular integral. Particular integral. I clearly mentioned this thing. Here you are using article 4.3. Look at here, 4.3. Here you are using for right hand side equal to non-zero. You are going to use article 4.4, and that is called yp. Combination of this yc and yp that will provide you the general solution. So my general solution is yx equal to yc of x plus yp of x, complementary function and particular integral. One more thing, when you solve the yp of x at that time, yp, particular integral, right hand side non-zero, at that time, make sure your function must be free from constant. Even though you are integrating your function, don't write constant of integration, because whatever constants you are getting over here, that would be merged with the constants here for yc. So you don't have to mention your constants every time. Suppose I'm getting some C1 and C2 over here, and here it is C3, C4 or C3. I can merge that C1 with C3 because here it is 2, here is 4. So 2 plus 4, 2 minus 4, something like that. Again, one constant, right? So don't write constant over here, yp. Keep your yp independent of the constants. This is about the solution of higher order differential equation. Now, one more solution I would like to provide you, that is called the superposition principle. Once you have, suppose, nth order differential equation, I told you second order differential equation means you have to have 2 solutions, third order 3 solutions, fourth order 4 solutions, fifth order 5 solutions, like this. That means nth order you will be having n number of solutions, 1, 2, 3, 4, 5 up to n numbers. N could be anything, n number of solutions. Now, if you combine all these solutions by multiplying these solutions by some constants, different constants, C1, C2, C3, C4 up to Cn, and put plus sign in between, that is called linear combination. So my first solution was y1, second is y2, third is y3, nth solution is yn. So suppose y1, y2, yn be the solutions of homogeneous nth order differential equation of type 6. Then the linear combination C1, Y1, C2. If you merge all these solutions like this, if you take the linear combination of the solutions, that will be again a solution of the given differential nth order differential equation. So linear combination, suppose I have one solution for my, let me go back. One solution is -2 and -3, right? So my first solution is, suppose y to the power, e to the power -2x. Suppose y, I will let you know. But my first solution, e to the power -2x. And another solution is e to the power -3x, right? If I write this e to the power -2x, multiplied by 2. So 2 e to the power negative 2x and
What is what on the
some constant and multiplication, linear combination. That will again a solution of the differential equation. So always keep in mind this thing that linear combination will provide you the solution of the differential equation again. That is the additional solution of the differential equation, linear combination. So please guys keep in mind this thing. And now linearly dependent and independence of the solution, I am quickly switching over to your first of the practice test. I'm switching over to first example of your practice test, right? You have any doubt so far, guys? Any doubt so far, guys? Sounds good. Sounds good. Okay, guys. If you have any doubt, I told you so many times, maybe last time in this chapter, you can stop me at the same time. I don't mind to repeat the things 2, 3, 4 times for you guys, right? If you are working with me, I will be really glad and I'll be happy with you too. So you can ask me a number of doubts, but you need to work with me. Don't ask me anything blindly without making any sense. If your question does make sense, I'm always here to help you out. And your question will make sense only after you work hard. So please make sure these things. Anyway, guys, yeah. But if you want to ask me some simple things, sometimes just to tease me, just if you want to, if you are kidding me, that's fine. I don't mind. If somebody want to ask me the question, hey, I forgot the definition of the derivative of sine x. Okay, fine, cosine x. Okay, but once in a while, not always. I'm kidding you guys. Okay, fine. Let's proceed further. Linearly dependence, abbreviated like L dot D dot, linearly independent of the solution L dot I dot. So many times you have gone through this type of words, linear, you have gone across this type of terminologies, linearly dependent and independent of the solutions, right? The things are what actually we mean by linearly dependent and independent of the solutions, how it works, how it follows, what's the geometrical picture of this type of things. That's what I would like to explain to you. Right now, I'm just working with just like your article, chapter 1. Look at over here, all these things. Solution of the differential equation. I just gave you the solution of the differential equation, but we did not solve any of the differential equations so far. I just gave you the linear combination. I'm providing you linearly dependent and independent of the solutions. This is just the introduction of higher order differential equation without solving an example, right? If you compare this phase, whatever I have started with this one, second phase, and if you compare with the first phase, my talk, my way of speaking, everything will go exactly parallel to your first phase. Because introduction portion, here also introduction. Whenever I'm going to start the example, solving example, I will let you know solving example. So everything goes just like parallel, phase 1 and phase 2 like this. That's the reason I like this book. Yep. Okay, guys, next. Linearly independence definition. A set of functions f1, f2, fn said to be linearly dependent on I, on some interval, because whenever you decide your function, suppose you have any solution, y1 is a solution of the given differential equation. That means that y1 is a function. This function is there, that means it has a prescribed domain, right? Prescribed domain. That means you have to fix your interval in which your function is well defined. Otherwise, it doesn't make sense. And that's why we went over your phase portrait, your previous example, example number 3 and 4. I told you how to fix the domain of the given solution of the differential equation, and if the initial condition is included, how it would be affected on your domain, what is a restricted domain, all these things we went over. Because without domain, not a single thing will make sense. Sounds good. Sounds good.
Yes, sir.
Oh my gosh. Sounds good.
Yes, sir.
Good. Solomon Harris, how are you?
Pretty good. How about you, sir?
I'm good. Thank you. I'm glad today I can see William. Hey, William, where is he? Oh, here he is. Good. So set of solutions, instead of y1, y2, y3, in your book it is mentioned f1, f2, f3, but you can consider y1, y2, y3 too. Nothing wrong. That is called linearly dependent if. This is a symbol of there exist, mathematical symbol of there exist. If, reverse epsilon you can say. If there exist constants, how many constants you require? N number of solutions are there. You have to have n constants, C1, C2, C3, and then make a linear combination. C1 F1, C2 F2, or C1 Y1, C2 Y2, Cn Yn, and that is equal to 0. But not zero, not all zeros at the time. Whenever you are talking about linearly dependent of the solutions, linearly dependent of the solution, at that time, this linearly dependent would be separated out from linearly independent if your constant C1, C2, C3 should not be zero, not all zeros at a time, not all zeros, right? At least one of them should be different from zero. At least one of them. Not all zero means at least one of them. If you are working with cubic equation, that means you will be having 3 solutions. That means you require 3 constants, C1, C2, and C3. Out of these 3, C1, C2, and C3, at least one should be different from 0. If C1 is 0, C2 is 0, and C3 is 1, sounds good. You are good to go. Makes sense. Good. My second definition, that is for linearly independent of the solutions. Again, my nth equation 6 and 7, in both the equations, our order is n. So nth order differential equation, oh my bad, I'm sorry. Nth order differential equation is said to be linearly independent if there exist constants. Again, I want n constants because n solutions are there. Linear combination equal to 0, provided all are 0. All your constants C1, C2, Cn, all are 0 at the time. That means difference between linearly dependent and independent is here at least one should be different from 0. Here all are 0 at a time. C1, C2, C3, C4 up to Cn equal to 0. Equal to 0. That's fine. That's fine. Why I said I want at least one non-zero. Again, maybe it's not given in the book. Just pay attention here. I want at least one non-zero over here. Why? Why? I'm explaining you that why. Why I like that word. Why? At least in math, not in general life. But for math, why provides you lots of new things. Why forces you to learn new things. Why motivates you to clear your doubts. So ask yourself, why I need this thing? Why I'm using this thing? Why not this one? And try to create the questions for yourself only and try to get the answers. Try to read the books. Try to discuss with your friends, with your colleagues. Try to figure it out. Finally, if you're not getting any of the things, I'm here to help you out. I will try my best. I don't say that I know everything, but I can try to answer your questions. Okay, guys? Whew, happy. Are you guys good? Are you guys good? Girls?
Yes, sir.
Yes, sir.
Nina? Good. Stay awake. Gage Levine, how are you?
Good, sir.
Good. Ismail Taylor is tired. Yeah, if you need some stimulator, I can give you a break after 10-15 minutes, okay? But please, 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 I think this today you need something. So after something means stimulator, okay? Not more than that, please, tea or coffee or some juice. Okay? Don't go
Yes, sir.
or anything more than that. Yeah, last semester I had one student. You won't believe he was in my Calc 3. Again, I will not disclose the name. And in his room, he has just on the back side of his chair, he has lots of alcohols. Yeah, I don't know whether he was taking the alcohol before the class or after the class, I don't know. But I told him, please, 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 don't take alcohol at least before the class or in my class. Then after, that's not my lookout. But you guys are good. You guys are really good. So just stimulator is allowed, okay? After 10 minutes, not right now. Nathan Light, are you okay? Feeling sleepy? Light.
I'm good.
You're good. Paul Mustaine, you must be happy, right? You got good grade.
I'm doing all right, sir.
Yeah, you got really good grades. I like your efforts. I appreciate. Just go ahead. Keep it up.
Thank you.
Yeah. Clean heart. Are you outside? Yeah, you are outside your home.
Yes, sir.
Yeah, looks good.
I'm in Williamsburg right now. I had to drive my mom out to work since I got
Okay.
a dentist appointment later today.
Mm-hmm. Oh, okay. Good. Margie, are you good?
Yeah, I'm good.
Okay, Nina. Nina,
Yes, sir. I'm good.
where are you?
Home.
I know home, but I can see you. I'm sorry. I can see you now. Yes. Okay. Ilyas Tyson, just work hard, okay? And if you have any doubt, please let me know. Guys, I would like to change little trend, at least for this chapter. Somebody left the meeting. I told you, if you are leaving the meeting, please let me know. Nathan Light. I don't like this thing if you leave the meeting, because if I want to say some important thing to you, you want me to wait for you? No. Nathan Light. Good. If you are leaving the meeting, at least let me know. Okay, I'm going to give you a break in 5-10 minutes. Just please have patience, please.
Sorry, I was getting something to drink.
I know, but yeah, I would like to change a trend. I mean to say that every day I'm going to teach you in the morning, and last 10-15 minutes, I would like to spend just for our revision, some doubts, some discussion, some question answers. Is it okay? So that you guys will be in touch with each and every questions, right? And if you like or not, I don't care about it. Yes, I don't, listen to me carefully. I don't care about it, but you have to answer the questions. Otherwise, leave it. But please be careful, guys. Please. Whatever I'm doing or I have been doing, that's just for your betterment. I'm not going to miss or lose anything. Or I'm not going to gain anything. But please, guys, pay attention and clear this course with good grades. That's the only reward to me. Okay, guys, let me continue for 5-10 more minutes, and then it will be a break time because I need some stimulator too. I'm speaking constantly since 7:30. I need some tea or coffee. Yeah, after some time. Okay, so this is a definition for linearly dependent and independent of the solution. And as I told you, how they are separated out. Suppose I'm working with second order differential equation. That means I will be having two solutions. If I want to write in a linear combination form, means I require two constants. So my first solution is f1x, second solution is f2x, and I want two constants c1 and c2. So let me write it down, c1 f1 plus c2 f2. This is called the linear combination of my solution. Agree? Now, suppose my solution is linearly dependent. Linearly dependent, that means out of these two constants, at least one should be different from 0 as per as definition. Am I right? Say something.
Yes, sir. Yes.
At least one should be different from 0. Suppose I would say C1 is different from 0. Suppose you can take C2 different from 0, your choice. Will, are you paying attention?
Yeah, sorry, my dog was going nuts. So
Okay. Yeah.
yeah, he's good now.
Okay. So suppose C1 is different from 0. C1 is different from 0 means C2 could be 0, could be non-zero. At least one means out of C1 and C2, at least one, either C1 or C2 is different from 0, right? But not C1 and C2 both, right? Because at least one should be different from 0, not all. Because C1 is different from 0, let me divide by C1. So let me send this one to a right hand side. So negative of, let me send this one to other side. So C2 of F2x. That is negative C2 F2x on the right side. Because C1 is non-zero, I'm allowed to divide by C1 because C1 is not 0. If C1 equal to 0, I could not, because 0 in the denominator makes my expression infinity. That doesn't make sense. So because my C1 is not equal to 0, according to the definition of linearly dependent of the solutions, I can divide by this C1, negative C2 by C1, F2 of x. C2 is the constant. C1 is non-zero constant. quotient will provide me another constant. I would like to write that constant as C. So f1x equal to C times f2x. That means I am providing you another definition of linearly dependence of the solution. Whenever, how many functions were there or how many solutions were there for second order? F1 and F2, 2, right? Out of these two, whenever one function or one solution can be expressed as a constant multiplier of the other solution, that is called linearly dependent. I repeat, whenever one solution can be expressed as a constant multiplier of the other solution, it is a linearly dependent. You can write, suppose I had chosen C2 not equal to 0. In that case, you could have received here f2x equal to C times f1x, right? So one solution can be expressed as a constant multiple of other solution, that is called a linearly dependent. That's not going to happen in your linearly independent solution. That means now it's time to explain to you. Look at over here, guys. Guys, one more thing. You know, I went to VMI last week twice just for you guys because I wanted to use this VCOM. Can you see me? I wanted to use this VCOM. And that's why I just went to VMI twice last week. But honestly telling you, it's not that, I don't like this thing. It's not that good. It's okay. It's okay. Not that good. Yeah, this one. Because only drawback is, everything is good. Only drawback is, if I want to write, see how we are habituated. I can use this pen and we are habituated to write it down. And I can focus all my, I can pay all my focus over here when I write down on my page, right? But it's very sensitive. I'm losing my screen here. Only drawback is I have to pay attention on the screen and I have to write it down over here on my desk. And that's hard. It's not possible because we are not habituated, right? If I ask you to write it down, that means naturally your eyes will go on your page like this, like this. I can show it to you. Look at over here. Okay. Before I start this VCOM, I just would like to explain to you linearly independent of solutions for the function. Suppose f1x is sine 2x and f2x is sine 2x cosine x. Okay, let me take f1x equal to this one and okay, good. Let me share my screen. How can I share my screen? I have to first stop this one. That's another drawback. See, if I want to share VCOM with you, my tablet, at that time, I cannot share both the screens. I have to stop one. So let me stop this one. And now let me share my screen, my whiteboard with you. My whiteboard is over here. My whiteboard is here now. Let me go for the text. And yes, look at here, guys. Suppose I am talking about right now linearly. Oops, what's wrong? Or draw. Okay. Suppose I want to go for linearly dependent of the solutions. And my function, suppose f1x, that is equal to sine of 2x. And I have another function. See, I have to constantly pay my attention over here. f1x equal to sine of 2x and f2x equal to, suppose, sine x times cosine x. Now, if I write f1x equal to sine of 2x, but sine of 2x by trig formulation, I can write it down in terms of 2 sine x times cosine x. But 2 sine x times cosine x, that is nothing but my f2 of x. That means my first function f1x is a constant multiple of the other function. Look at over here. And that's why it is linearly dependent. Constant multiple of other function linearly dependent. If you want to draw the graph of the function at that time, what will happen? Suppose this is my sine x. Suppose my one function y equal to, suppose y equal to x. Y equal to x is this line. If I say suppose y equal to 2x. Y equal to 2x. That means x is this one. Y equal to x means this is 1 and here it is. Here it is 1. So y equal to 2x will be something like this. Y equal to 2x. That means whenever I say linearly dependent, that means I'm just extending my graph, extending my figure. If I have a suppose quadratic function, Oh my gosh, either I can pay attention here or there, but together, how can I pay the attention at both the places? Suppose I have one function y equal to quadratic function y equal to x square, right? This is the non-linear function. This is the non-linear function in some domain over here, in some domain, suppose -2 to +2. And if you extend these lines in the domain, suppose -4 to +4. Right. So you're linearly dependent. That means you are extending your solution, whether it is linear or non-linear, but you are extending your solution. Suppose I have here it is y1 and y2. Suppose I can write my first solution y1 equal to negative of y2, negative x of y2, or negative of x, I would say, negative of x. So this is y equal to x, y1 equal to x is one of the solutions, and y2 equal to negative of x, second solution. So y1x is moving like this, y2x is in the other direction. So y2x, I can write it down, that is equal to negative of y1 of x, negative of y1x. So again, you can see that this y2x is the thing, but negative of y1x is a linear combination, constant multiple of other solution. That's why it is called the linear combination. It is called the linear combination. I would say it is called constant multiple. You are just extending your figure. That is called the linearly independent of the solution. But for linearly independent, what will happen? That you are not allowed to write that f1x equal to c times f2x or y1 equal to c times y2. No. Suppose, oh my gosh. Sorry. My eraser and okay. So linearly independent. Linearly independent, suppose I get my y1, my first function y1x equal to suppose x, and my second function y2x, that is equal to suppose absolute value of x. Now y1x equal to x, the graph will go like this, y1x equal to x. But y2x equal to absolute value. Now I'm not extending. If you want to extend, you have just two possibilities. You can either extend in other direction, or you can extend in the same direction. That is called the linearly independent of the solution. But y2 equal to absolute value of x will give you the graph like this. y2 equal to absolute value of x will give you the graph like this. And you can see here, I am not extending anywhere my line y equal to x. So there is no relationship between your solutions. That is called linearly independent. You can see the graphic purpose. And if there is a relationship, if you are extending your graph, that is called the linearly dependent. Does it make sense? Does it make sense? Oh my gosh. Does it make sense, guys? Now I want somebody to give me, shall I erase all this part? Shall I erase all these things? I'm asking you guys. Shall I erase all these things? Oh my gosh, it's too much.
Sure.
May I erase all these things? Okay, let me erase this thing. Nina, give me the first example of your practice test.
Yes, sir. The f1 of x.
Slowly. So f1 of x equal to, go ahead.
Cosine squared x.
I can't hear you.
Cosine squared x.
Cosine square x. F2 equal to?
F2 equals sine squared x.
Sine square x?
Yes, sir.
Sine square x. Then f3x equal to?
Secant squared x.
Secant square, you said, right?
Yes, sir.
Secant square x. And f4x equal to?
Tangent squared x.
What is the question now?
On negative pi over 2.
Okay. This solution is defined from negative pi over 2 to pi over 2. Okay. Then?
Yes. And that's it.
That's it. Now, what's the question? Read the title.
We have to check whether the set of the function is linearly dependent or independent. And then
Okay, guys, the question is something like this. Thank you, Nina. See, these 4 solutions are given to you of some differential equation. We don't know that differential equation because we are not concerned about that right now. So you can say like this, that these are 4 solutions of some differential equation, 4th order differential equation. And we want to make sure whether these 4 solutions, you can say this one y1, y1, y2, y3, y4. You can say like this. These 4 solutions are linearly dependent or independent. Always, it's not advisable to go for the definition. Yeah, there's another trick. Sometimes you can use your own trick also. Like, if I want to see, first of all, I have to go for the linear combination. Linear combination, that means I can write C1 F1x plus C2 F2x plus C3 F3x plus C4 F4x and equal to 0. Agree? F4 equal to 0. Let me plug the values. So this implies that C1 times F1x equal to cosine square x, F2x, I'm sorry, my bad. C2 and here it is sine square x, then C3 and here it is F3 equal to secant square x, and C4 and F4 equal to tangent square x, and that is equal to 0. Now guys, make sure, if I want to go for, I want right hand side equal to 0. First of all, your target is there that you have to arrange your C1, C2, C3, C4 in such a way that you are getting your right hand side equal to 0. First of all, I would like to consider here and here. I would like to focus here and here. If I say suppose C1 equal to C2 equal to 1, that means I'm going to get cosine square x plus sine square x. And what is the value of cosine square x and sine square x? This will provide me 1. Agree? Oh my gosh, say something.
Yes, sir.
Yes, sir.
Right? Now, plus something which I don't know, equal to 0. So this value is 1. I want something over here which will make my right hand side equal to 0. What is the value I'm looking for over here so that my right side will be 0? What is the value I'm looking over here so that my right hand side equal to 0? -1. Agree? Are you getting me or not?
Yes, sir.
Yes, sir.
Right. Now, which value will make -1 over here? Again, go for the identity. You know this thing that secant square x minus tangent square x equal to 1. Agree? But I want -1. That means if I multiply by negative, so negative of secant square x plus tangent square x equal to 0. Agree? That means if I consider my C3 equal to -1 and C4 equal to 1 over here, these choices of C1, C2, C3, C4, look over here. These all choices of my C1, C2, C3, C4 that satisfy this left hand side equal to right hand side 1 minus 1 equal to 0. That means my particular values of C1 equal to C2 equal to C4 equal to 1 and C3 equal to -1. So that means my solutions are linearly dependent because none of them is 0. Right? At least one should be non-zero. Here all are 0. All are 0, that is allowed. At least none should be 1, 0. At least one should be non-zero. So that means this solution is linearly dependent. But you have to mention like this, whatever I explained to you. You cannot say directly that, and yeah, one guy was there last year in my section and he said that I counted in my head and that's why he wrote it down just equal to 0 and linearly dependent. And I cut the points. And he said that I just counted in my head. I can't read your head. Whatever you are going to write on the screen, I mean to say on your page, I can read only those things. Please don't argue like this, please. Sorry, guys. So, yeah, so that's how it works. Now, may I clean this screen? Can I erase this part?
Yes, sir.
Please say something.
Yes,
You're
sir.
irritating me, guys. I'm asking you so many times and you don't reply. You are irritating me. Don't do this thing, please. Right?
All right.
Dr. Dimple.
Yes.
Sir, I realized I should have told you about this a couple of days ago, but yesterday I received confirmation that I can clear out my VMI room today at 3 o'clock, and I
Okay.
live 3.5 hours away. So is it okay if I watch the rest of the lecture for today on YouTube?
Rest of the lectures. So you are leaving right now, right?
Yes, sir. I need to leave within like 10
I can
15
understand.
minutes.
I can
Okay.
fully understand. Yeah, no problem. Yeah, let's
Thanks,
try
sir.
to watch the videos and everything, because as we discussed, just wait. As we discussed today or tomorrow onwards, we are going to spend last 10-15 minutes just for the discussion, solution, questions, answers like this, like
Yes,
a
sir.
debate. Okay.
Understood.
So
All right.
yeah, if you are not watching the videos or try to go through the lectures, I will realize this thing. So don't do this thing.
Understood.
Thank you so
Understood.
much. Yeah, you can go there. Thank you so
All right,
much.
thank you.
Thanks for letting me know this thing. Okay, guys. So let me clear these videos and this drawing, and let me stop this sharing this one, and I again go back and share my screen with you. So look at over here. This is what I explained to you. This is what I explained to you. Now, this is all about Article 4.1. Now I'm going to start Article 4.2, in which one solution will be provided to you. Second solution we are going to find using one formula, and after the break of 5 minutes. Take just 5 minutes break, and I want to see all you guys after 5 to 6 minutes, not more than 6 minutes, please. Break.
All right, sir.
Okay, guys, let's go back. What we did. Okay, let's start. All of you are here? All of you are here?
Yeah, I think so.
Good. Okay, guys, so that's what we mean by linearly dependent and independent of the solution. So first example I just solved. And question number 1, first part, Nina explained to me and I solved that example. And question number 2, 3, 4, question number 1, part 2, 3, 4, that's in homework. Now let's go for, sorry. Now let's go for second part. Question number 2, A part, that is article 4.2. You can see over here, second order differential equation, y double dash. Minus 7x y dash plus 16y equal to 0. One solution y1 is provided to you. We are looking for second solution. This type of differential equation at that time, first you have to use the formula. This formula you have to use. Equation that is of the type y double dash. Look at over here. You have to have the coefficient of y double dash 1. Before you proceed further, before you apply this formula to find the second solution of the differential equation second order, you have to make sure that coefficient of the highest derivative y double dash is 1. is not 1. Suppose x is there. Divide by that x throughout, like this. Here x square is there. Coefficient is not 1. I want to make it 1. Let me divide by x square here throughout. If you divide here by x square, you're going to get negative 7 by x. If you divide by x square, 16 by x square here, like this. And then I put the circles to let you know that this is my P and this is my Q. P and Q here. I don't need this Q, so I just forget this. Let me forget this Q. We don't want it. We just want our P. Because P appears here in the equation, in the solution. Y2 equal to, my second solution is given by y1x. Whatever solution is provided to you, by x to the power 4. And integral sign, division by y1 square. So what, y to the power 4 and square, look at here. And e to the power negative p is, please, you have to have plus sign here. Look at the plus sign here. You have to have plus sign, so take this negative inside. So negative 7 is my p. Don't say p is 7 by x, you will be wrong. It has to be negative 7 by x. So negative 7 by x is my p. This negative will become positive. 7 is constant, just pull it out the integral sign and you are going to get integration of 1 over x is ln x. So 7 times ln x. Again. I told you so many times that we are going to use this formula ln of a to the power b equal to b times ln of a more than 100 times in this course. One more. So a ln of b is ln of a to the power b. So e to the power ln of x to the power 7. Once you have coefficient of ln is 1, you can cancel this exponential and logarithmic function. They are inverse of each other. And x to the power 7. And integration 1 by here x to the power 8. So 7 and x to the power 8 will get cancelled out. You're getting just 1 over x. And 1 over x is, you are getting just 1 over x. And integration of 1 over x is ln x. And that's why x to the power 4 ln x is the solution. And that's what I gave to you in your answer key. Example is homework C. I just took this example number C. X squared y double dash minus 3xy dash plus 5y equal to 0. First solution is this one. Back here also x square is there. Let me first divide by x square throughout. So my p is this one, negative inside. Q is this one. I don't want q. I'll be working with p only. Y2 equal to y1. Y1 is my solution. E to the power negative p. 3 by negative 3 by x. And y1 square. So x to the power 4 and cosine ln x. Integration is little bit, I mean, is good here. You have to just pay attention for your integration portion here. You have to make sure about your integral sign. So negative is positive. 3 is constant, pull it out. 1 over x is integration ln x. So ln of, you can see here, 3 times ln x, right? So you can take this coefficient as an exponent. You're going to get x cubed divided by x to the power 4 cosine square. This will get cancelled out. So your ultimate expression is integration 1 over x times cosine square ln x. If I take ln x equal to u, 1 over x dx equal to du. So this 1 over x, this x is left out. Look at my cursor. This x is left out. And 1 over x, because 3 and 3 gets cancelled out. Just 1 x is left out. 1 over x is my du. So this is my du. This portion will give me my du. This portion will give you du. And here is cosine square u. Cosine square u. Means secant square u. And use the formula. Integration derivative of tangent x is tangent u is secant square u. So integration of secant square u is tangent u. So this is tangent is nothing but sine over cosine. This will get cancelled out. So x square sine ln x is my answer. That is my second solution of the second order differential equation. So far, I have not taught you how to solve this differential equation. I'm just giving you the way to figure it out, the second solution, when the first is provided to you. But in the next article, we are going to see how to solve actually the differential equation of higher order, second order, third order, fourth order with homogeneous right inside 0. Right? But right now, one is given, another we are looking for. Okay. One more. Question number 3 from question 1. Question number 3 from practice test 1. Cosine, sine square, secant square, tangent square. I think we already solved this one, right? Yeah, one.
Yes, sir. We solved it.
That's the same solution. That's fine. Now, another way of looking at the linearly dependent and independent solution is through the Wronskian. Yes. fantastic way of finding this one. Look at here, guys. And very easy way. Suppose F1, F2, Fn, they are the solutions. Suppose you are working with cubic equation or order 5, differential equation order 5. That means you have 5 solutions. Write down all your 5 solutions here. 1, 2, 3, 4, 5, just in first row. Then go for the derivative. How many times? 4 times. 1 less than your order of the differential equation. So go for 4 derivative. Here it is nth order, so n minus 1th derivative. So first derivative, second, third, up to n minus 1. Second function, first derivative, second, third, up to n minus 1. If it is 5th order, go up to 4th derivative. F1, F1 dash, F1 double dash, F1 triple dash, F1 to the power 4. Same here, here, and here. And then open this determinant. If you solve this determinant, this is a determinant, please. If you solve this determinant, and if you are getting different from 0, means linearly independent. And if you are getting equal to 0, linearly dependent. Simple. Linearly dependent. As for example, suppose one of the solutions of y double dash minus 9y, second order differential equation. 2 solutions are there. One is e to the power 3x, second is e to the power negative 3x in the range of negative infinity to infinity. If I want to apply this Vronsky, so Vronsky of y1, y2 equal to y1, y2, my function as it is, first of all, and then the derivative. 2 solutions are there, means 1 less derivative. So just first derivative, y1 dash, y2 dash. So this is my Vronsky. Function and its first derivative, second function or second solution in the derivative, 3 minus, negative 3 minus 3 equal to negative 6 equal to 0, not equal to 0. That means the solution not equal to 0 means they are linearly independent. Simple. They are linearly independent. Right, guys? Good. This is another notes. I have 2 notes, so that I just posted everything. Sometimes people are asking that we went through the uniqueness and existence and uniqueness of the solution for the first order, first degree differential equation, theorem 1.2.1. What's about the higher order? Yes, it is there. If a1, a2, an minus 1, all your coefficients, see a1x, an minus 1x up to a0x and right hand side. All these functions are continuous in the interval and anx is not equal to 0 for all x in the given interval I. If x equal to x0 is any point in the interval, then the solution of the initial value problem exists and it's always unique. So uniqueness for higher order differential equation also exists, right? Also possible. This is the second order differential equation with 2 initial conditions. 0 and 0 are there, so initial conditions. And y equal to the power 3x, this is the solution. This is called the initial value problem. And this initial value problem is a unique solution. This is the unique solution in this domain. Because 0 and 4 and 0 and 1 both appears over here in this one. Actually, the domain of this one is negative infinity to infinity. But these 2 initial conditions are lying just in this portion. So that's why it is 0 to infinity. Okay, guys. Superposition again, it's a collection. Superposition is the same thing. It's a collection of linear combination of the differential equation. Linearly combine. Few examples are there. Linear combinations. So I would say it's just a repetition of class notes with little bit additional things too. Vronsky. See, another example. Suppose your first solution is sin x, second is sin x cosine x. That's what I took when I was using my whiteboard, my tablet. I can use now the same thing for, at that time I used the definition. Now I can use a Vronsky. Sin 2x is 2 cosine 2x, sin x cosine x product rule, cosine square x minus sin square x derivative. If you open this one, you're going to get 0. Means linearly dependent solution because it is 0 now. So either way, you must get the same answer. Either way, you must get the same answer. Right, guys? Some reviews are there. You can ignore this thing because already you took your exam based on differential equation, exact, first order, first degree, exact, and nonlinear. So you can ignore this part. But that is probably a good revision for your final if you want. Otherwise, just ignore it. And article 4.3. Now it is up to you. You want me to continue with article 4.3? If you want, I can stop over here and we can continue this article. tomorrow. And I would like
Tomorrow would be good.
Nina is there. Who is there? Nina?
Yes, sir. I agree with tomorrow.
Okay.
Yeah, I concur.
Okay.
Yeah, I'm moving out of my apartment right now, so.
Okay.
Yeah, I'm moving on Saturday, and I still
You're
need to
moving
finish
on Saturday for what? For to VMI?
down to Raleigh
Or down
for
to
my job.
I'm in Raleigh.
Wait, you're
So you're
moving
in
to
Raleigh
Raleigh?
too?
Oh,
No,
yeah.
I go to NC State, so I'm in Raleigh right now. Like, that's where I usually am, but I'm moving back to Virginia because that's where my home is.
Oh, you are from Virginia, Margie?
Yeah, I live in Charlottesville. That's why I'm taking classes through BMI.
Oh,
Weren't you
now
in
that makes
Charlottesville?
sense to me. I was wondering that you are in North Carolina, Raleigh, and why? Oh, that makes sense. More sense to me.
Yeah, because in-state tuition over the summer.
Okay. So this is your first course at VMI?
Yeah.
Okay. Now this makes perfect sense. I was wondering.
Yeah.
Okay.
Well, I'll be in Raleigh. So, well,
So why are you in Raleigh? Why are you not at home? Because everything.
Well, I had my apartment leased until the end of the summer, but because of everything going on, I'm just moving out now.
Okay.
So I was in Virginia, but now I'm here.
Okay.
Moving out. Yeah.
Good. Nathan Light, why are you looking so tensed? What's the problem?
Oh, sorry.
Are you good?
Yeah, I just got work.
See, whenever somebody feels depressed or not, if somebody is not doing good, look at Gage Levine. He's always smiling. Look at him. Always smiling. See, I like it. Alex, see, always good. Always a smiling face. Okay, guys, if you have any doubt, whatever I taught to you today, Article 4.2, if you want me to some of the things, if you want to discuss some of the things, if you have some doubt, please let me know, please. Margie was the one who asked me for the solutions, and I promised her that I will provide you solution for the major chapter. That's the main chapter, chapter number 4, and that's what I did.
Thank you.
Okay?
Thank you, sir.
Yes. Any question? Any suggestion? Anything for me, guys? But if you want to discuss something in between, I don't mind. In my presence, please go ahead.
No, everything is fine.
That sounds good. We'll host Statler. I'm happy to see you.
happy to see you too, sir.
Yeah, you know, if you are speaking and if I don't see, I just got upset that why I can't see this guy. I just want to see his face, but I'm good now.
Well, now that I figured out a way, because what I did is I jerry-rigged an old speaker. So instead of making something out of wood, because I couldn't find the right wood, yeah, I just found some old like equipment and stuff and jerry-rigged the speaker so I can have it with my phone on it.
Okay, guys, one more thing. Without disclosing the name, but couple guys, they did not perform well in our exam 1 and exam 2. Those two guys, I would like to give them one more opportunity. Do you want to go for retake? I know right now I'm too busy, but even though I can find some time for you and I will allow you to go for retake. So if those two guys, they want to, those who got less than 70, and I can't give them more than 70 guys because I don't want to do any kind of injustice to other guys. So if those two guys, because they know this thing, I can't want them to feel bad. So, but they know this thing, I know this thing. So if they want retake, just send the email to me. And if they don't mind, we can discuss right now too. Otherwise, it's your choice. But I can provide you that facility. But this is the final last one-time opportunity, guys. So if you can go for retake for both the exams on this Sunday, not Sunday, yeah, Sunday. First of all, you decide whether you want to go for retake or not. And I have not graded your homework, but I hope all you guys have submitted your homework on Canvas. I will very soon. Today I'm very busy because I have a couple appointments in the afternoon. 2 o'clock, 3 o'clock, and 4 o'clock, 3 appointments. I'm busy today. But most likely tomorrow or day after tomorrow, I will try to go through your homeworks and I will grade your homeworks too. Homework, we will discuss this thing. Right now I'm on Zoom recording, so I don't want to disclose all these things, but almost at the end of the syllabus, semester or summer session, we will have a Zoom meeting without recording, because I'm posting all these videos on YouTube and I don't want to disclose those things. But we will be having one meeting, maybe after a week or like this or a couple of weeks, and we will discuss lots of things in your benefit, right? Lots of things in your benefit. Trust me, guys, whatever we have been doing or I'm going to do for you, I'm going to do, that will be in your benefit, guys. Sometimes you may find this thing that I'm getting strict. Yes, I know this thing. Intentionally, I'm doing that thing because I just want you to work hard. I just want you to work with me. That's what I want. I don't want anything else. Guys, at the end of the session, I'm pretty sure you will appreciate me. Yeah, right now you may feel that I'm giving you some hard time. That's fine. Okay, I don't mind. Sometimes I'm not. See, somebody is asking me same question 2-3 times. I just reply him or her once intentionally. But I think he realized this thing, right? He or she realizes this thing. Anyway, but guys, please cooperate me. Try to cooperate yourself. Any doubts, any kind of doubts are most welcome. Most welcome. If you want to share with me your personal problem, okay, I will try my best to help you out. Any kind of problems, because sometimes if you are stuck with some personal problems, you can't focus on your study. So I don't want to involve in any kind of your own personal problems. Only thing is, if I will be helpful to you, at least be able to focus more on our subject. That's the reason. So if you want to share anything with me, if you have some problems, some trouble, some things, or if you have good things in general, please go ahead. If you want to make everyone laugh, if you want to share some jokes, go ahead. Nathan Light, do you have any jokes with you? You want to share some jokes?
I have any jokes?
No.
No, I'm not funny.
You're not funny?
No.
Somebody here, Will can do that thing, right?
You want a joke?
Yes.
All right.
Loudly.
What do you call it when Batman skips church?
Batman gets okay.
Christian Bale.
I can't hear you, please.
Did you not hear it?
Yes, now I can hear you, yes.
Okay. I said, what do you call it when Batman skips church?
Answer him, guys.
Christian Bale. Get it?
Christian Bale.
Yeah.
Good.
Woo.
Okay, guys. Thank you so much. So, shall we stop here?
Yes, sir.
Permission? Okay, guys. So, I'll see you tomorrow. And again, just try to go through all these things. And if you have any doubt, let me know. Tomorrow we can. It's not like this that whatever we are discussing, you can ask me the question from that person. No, you can ask me the question from the previous lecture too. Any kind of questions are welcome, right? Just clear your doubts. Thank you, guys. Let me stop you with article 4.3 and 4.4 tomorrow. Tomorrow's class is very, very, very important. I request all of you to have at least 2 cups of stimulators before we start our class. Yes. And I will do the same thing. Okay. Because tomorrow's class is very important. Very, very, very important. If you miss a single point, that means you're going to miss lots of things. So I don't want any one of you to struggle. And that's why I just want you to pay your full focus. One of my guys, let me share one thing with you. One of my students in Calc 2, I have this time 23, I think so. 23, 24 Calc 2 students in summer session. First time in last 10, 12 years. Usually I have 8, 10, not more than 10 or 12. This time almost more than double. And one of my students, he told me that you are doing meditation in all your sections when you are on post. Then why not online? And I said, oh my gosh, that's fine. Are you guys aware of meditation technique? Meditation.
Yes, sir.
Yeah, those
My dad meditates
some
a lot.
courses with me previously, they know it very well. Roderick, she knows this thing, right? Nina?
Yes, sir.
Yeah. So if you want me to start the meditation in our session, I don't mind, guys. We can spend 10 minutes for meditation. There are lots of benefits of meditation. And it's not illegal to do the meditation in our class time, because so many universities in United States, they have separate meditation block, separate building for meditation, like South Florida University, San Diego, some universities. I don't have perfect names right now. Some of the universities, they do allot some building, some funding, some time for the meditation. If you Google, I can give you lots of links. Yeah, lots of benefits of meditation. You won't believe, but every daily I'm getting up early morning at 5:30. Yeah, and I'm done. Means I just get ready at 6:30, and 6:30 to 7:30. That is my meditation time. And 7:30 I start my class. Yes, every day 1 hour meditation. That will keep your mind healthy. And healthy mind means your body is healthy. Your body is healthy, mind is healthy. You can do miracles, right? Lots of benefits are there. Yeah, if you are meditating constantly for 90 days, you can find the effect only after 80 to 90 days. You will not get the immediate effect. But without making a break, if you do meditation for 80 to 90 days, you will realize this thing in the fall semester. Yeah, your grasping is just boost up like anything. Your grasping, you are in boosting up your grasping. Your memory power is just increasing like anything. You will find lots of good things. Your attitude, your mind is cooling down. Yeah, if some people are really very aggressive. Yeah, and if you think that you are also one of them, no. After meditation is the only medicine for you. Yeah, it's a medicine. It will help you a lot in all aspects of your life. So you just decide in between. I'm not forcing you. Yeah, of course, we are going to start the meditation in my Calc 2 session. But if you guys want the same thing, just for 5-10 minutes, not more than that, I can let you know. I can teach you that technique also, and we can start the meditation in our session too. But that is by your, that's only after your permission, right? I don't want to force anybody. I don't want to do it. One more thing, it has nothing to do with any of the religions. We are doing meditation on post when we were on post. Myself and Holly Richardson from, I think, psychology, and Matt German. So we are doing meditation. We used to meet twice a week, Monday and Thursday, around 11 or lunchtime, in library 5th floor for meditation. Yeah. So if you're on post, you will get that message probably via my email when we start the session. You can join us on the post, or we can do here tomorrow onwards up to the end of the semester. But it is absolutely up to you. We will go for the majority. If suppose out of 10, suppose 11, out of 11, suppose 5 students say that, yes, we want to go for meditation, and others are not interested, sounds good to me. They just keep quiet, don't disturb us. And whether they want to join us for the meditation or not, that's their personal, absolutely their choice. Okay, guys, just decide in between and let me know by tomorrow. Sounds good? Here?
Sounds good.
Yes, sir.
Thank you, guys. Thank you so much. And still, I can see that some of you have not prescribed my videos on YouTube. So please do that thing, and you can click the icon. One icon is there. So just try to click that one so you can get all my videos in sequence, one by one. So you know that thing, right? So do that thing, and so you don't have to open everything every time YouTube, and yeah, you can get everything in a sequence. Thank you, guys. Stay safe. Stay healthy. Yeah.
Have a good day,
Enjoy
sir.
your day. Bye,
Have
guys.
a good day, sir.
You too. Thank you.